Good morning, grade 12s. Today we are going to look at calculus, and under calculus we are going to look at few questions. The first one being finding the derivative of a function, yeah, from first principle, and or using first principle. Then after that, we're going to look at derivative laws. Um, Now, looking at this question, question 8, uh, given f of x, or the function of x, equals to x cubed minus 3, use first principle to find f prime x. F prime f, remember this thing, this is the derivative. What do you need? My recommendation is that you must remember the main equation of your derivative is written in this manner. F prime x equals to limit as h tends to 0 of f of x plus h minus f of x divided by h. What we need to remember here is that we can never substitute 0 here or h with 0 because h is a restriction. So h cannot be equal to 0. Why is it that h cannot be equal to 0 at this point in time? It's because once you substitute 0 in this equation, this whole thing is going to be undefined. Now, it is a restriction. What we need are two equations. We need to know what is an equation of f of x. We also need to know what is an equation of f of x plus h. All right, your f of x is given, which is x squared minus 3. All you do is to use f of x to determine f of x plus h. So by substituting x with x plus h. So here you will get x plus h all squared minus 3. Now, you have an option to actually distribute this further, or you can just substitute and distribute in the equation. Preferably, I would say simplify this equation of f of x plus h so that you substitute easy. So here what you would do, you would then distribute, remember this is a square binomial. When you square binomial, we are then going to just square the first term, which is x squared, multiply x and h, and then multiply the answer by 2. So x times h is xh times 2, you get 2xh. And then lastly, square h, which is going to be plus h squared, and then minus 3. Now, we have our two main equations that we need in our application or in our calculations or calculation of derivative. We now have to substitute these two equations here. Do not stop writing the limit. The only time that you stop writing limit h tends to 0 is when you substitute the values of h. For now, bear in mind I said h cannot be equal to 0 here at the beginning because we can never divide by 0. All right, so we're going to write limit h tends to 0, and then we substitute our two equations. Our f of x plus h is x squared plus 2xh plus h squared minus 3, then substitute, and then we have to subtract f of x. So we're going to say subtract, our f of x is going to be x squared minus 3, and everything has to be divided by h. All right, next, what we do, you can see we have to distribute this negative 3, negative 0 into this expression. All right. Again, our next step, we still continue with our limit. We write limit h tends to 0, and then we have our x squared plus 2xh plus h squared, and then minus 3, multiply this bracket by negative, you get negative x squared, and then you have plus 3. Everything has to be divided by h. And then you can see you've got like terms that are going to subtract. So x squared will subtract x squared, and then negative 3 will subtract positive 3. What we are left with is going to be limit h tends to 0 of 2x h plus h squared. Now, when you get to this step, you then have to factor out h. So maybe I must write it down. Factor out h. The main reason is to eliminate this h as a denominator there. Now, you'll write limit h tends to 0. Factor out h, you're left with 2x plus h. Divide by h. Now, h will cancel h. We will then be left with limit h tends to 0 of 2x plus h. Now we know we are safe. We can then substitute h, h equals to 0, because we know we are not dividing anything by 0, or we are not dividing this expression by 0 and equation by 0. Our final step is the moment you substitute 0 or h with 0, we then stop writing limit. So our final answer will be 2x plus 0. My apologies there. And then finally we get 2x. Let's bear in mind your 2x, as you can see, your derivative in this context is going to be another function. We're not going to get into details as to why that happens. I want us to look at the process in finding your derivative of a function, or the derivative from first principle. So a recap on this is 1. Remember, we can never substitute 0 at the beginning because h cannot be 0 only at the beginning, because we can never divide by 0. Our solution will be undefined. Number 2, you need to determine your 2 equations that you would have to use based on the equation that is provided. So your f of x and your f of x plus h. So to determine your f of x plus h, you then substitute x with x plus h, using the f of x function, or f of x, using f of x function. Simplify your f of x plus h function, and then substitute accordingly. Ideally, what you should know is that if you have substituted your f of x plus h correctly, your whole function of f of x will be eliminated, or it will be subtracted. Now, after that, your next step is to factor out h, so that you can eliminate or remove that h, which is your denominator. Once you're done eliminating your h as a denominator, you then substitute h with 0, and then you find your final product, all right, or final answer. Right, that is all about derivative from first principle. I want us to look at how to find derivatives of expressions and derivatives of equations using derivative laws. So, derivative laws, the key thing that you need to remember is that if you will be given three notations, and maybe I should actually cover that first before we do the question. You will be given three notations of either an equation, a function, or um, an expression. If you are given an equation, the equation is written as y equals to some something here. So maybe let's say y equals to 2x plus 5. So this is an equation. So to find the derivative of this equation, you will then um, use dy dx. So dy dx is a notation um, on a condition that we are given an equation, just like what we have here as an example. Contrary to that, which is not contrary anyway, the other option that can be given is that you will be given a function. So if you're given a function, in this case, it can still be the same equation. So the function in this case, the notation of finding the derivative, provided that you're given a function, is f prime x. Um, on the other hand, you may be given an expression. Now, if you're given an expression, you'll notice that an expression, it cannot be equated to anything. Just like, let's say, if we take 2x plus 5 as an expression, and the notation that will be given to you that indicates that you have to find the derivative of an expression will either be given as dx, and then your expression will be contained inside the brackets, which is 2x plus 5. Or the other option that can be given in this case is that your notation of an expression can be written as d over dx of the expression 2x plus 5. So your notations are very key for you to know exactly how to find all what they really mean. So these are all the derivatives. So what we have here, these are all the derivatives. But these are derivative notations um, depending on what is given to you. So these are all derivatives. All right. Now, I want us to look at this example here. Before you can do anything, when you're given a complex example like this, or a complex question like this, is to always write, maybe I should write it here, always write your equation or expression, always write the given question in standard form first. So your standard form of any question that's given in this case, it will be something that looks like this. Like, let's take this example that we have y equals to whatever. So as a fraction, so we need to ensure that our standard fraction of y will be y equals to ax to the n plus bx to the n minus 1 plus cx n minus 2 da, 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 da. So this is going to be the standard way of writing this expression. So we have to actually change this expression and write it in such a way that it is in its standard form. So how do we do that? Because this is a mere example of an expression, cannot factor out. So we have one term divided, or two term divided by one term. So what we're going to do, we're going to split these two terms. So we'll get y equals to 9x to the power of 4 divided by 3x, and then minus 6 divided by 3x. Secondly, we we then have to remember our exponential laws, and especially when it comes to this part here. Um, your key focus is on x, but not on a coefficient of x. Please be careful about that, students. You focus on x, not on the coefficient of x. So even though x is a denominator, the coefficient of x, you leave it as a denominator, but you have to change, apply the exponential laws on x only. Right. So let's move on. I'll just show you with an example. So what we're going to have here is that 3 divides into 9 two times, and then x to the 4 divided by x, we get x to the 3. Subtract 3 divides into 6 two times, and then this x, because it's a denominator, we then write it as x to the power of -1 according to the exponential law. Now, you can see that this expression or this equation that is given to us, it is now written in its standard form. That's what we're looking for. Once we have our equation in a standard form, we can then use the derivative. Up to here, this is what I have as my equation in its standard form. Now we can derive your dy dx, which is what we are looking for, will then be, you take the exponent. So the law that we are going to apply if you're given y equals to a x to the power of n, we are deriving the equation of x of the equation of y in terms of x. The law states that we will then write dy dx. We focus only on the exponents of x. We will then multiply x with our denominator, with our coefficient, and then subtract 1. So what we are going to have will be a times n, or n times a, and then x to the power of n minus 1. So we subtract 1 for each and every term that we have, depending on how long your expression is. So this is the law that we are going to apply, which is the short principle. Here, we'll take the exponent of x, multiply 2 with it. We then get 6, my apologies. Again, that's going to be 6. 3 times 2 is 6. And then we go back to the exponent x, we subtract 1. So we're going to get 3 minus 1. We are done with term number 1. We then go to term number 2 and apply the same law. We take -1, multiply -2, which will give us +2. And then we go back to the exponent and subtract 1. So -1 minus 1. So first you multiply the coefficient by your exponent, and then after that you subtract 1 from your exponent. Right, our final answer that we get is going to be 6x to the power of 2 plus 2x to the power of -2. Preferably, always write your final answer with positive exponent. Remember, for us to end up with x to the power of -1 is because x was a denominator. So we end up with x to the power of -2. It means this x to the power of -2 has to go back to a denominator, or to be turned into a denominator. So you'll have 6x to the power of 2. 2 does not move with x to the power of -2. So 2 becomes your numerator, and then x to the power of -2 becomes x to the power of 2. So this is how you would find your answer. Try as far as possible to leave your answer in with a positive exponent, unless the instruction states otherwise. All right, let's look at the next question. Again, I want us to look at how the question is phrased. So you would notice here the notation that we had to use for dy dx, which is dy dx for our derivative, was because the question that was given to us was an equation of y. Contrary to the second question, here we are given an expression of 2x plus, which looks like 2x plus 5 in this case. And then I said to you, you will then be given two notation, or you will then be expected to work out the derivative according to the notation that's provided. All right. We are given the second notation of an expression. The key thing that you're going to do here, you still apply your first basic law. Make sure that everything that you have here is written in its standard form. So we're going to apply all laws of exponents. Remember your roots, what they mean. Your roots are actually rational exponents, and your rational exponents are fractions. So if you look at the cube root of x cubed, when we simplify that, we are then just going to get x. But before we do that, it is important for you to notice that you will not or you shouldn't change your notation while you are simplifying the expression inside. So you still write the notation d by dx. Now we simplify until we get our standard notation. So what we're going to get, I'll write it as x, the cube root of x cubed, as it is written, divide by 3x and minus 2x root x divide by 3x. I've got my two terms. Next, I'm going to simplify this expression. So d by dx, we still write the expression inside the bracket. The cube root of x cubed is just x, and x over 3x, x is going to cancel x, which we are fine. And then the minus your second term, which x cancels x, and you are left with 2x 2 root x divided by 3. Thirdly, we then still rewrite this equation as d by dx, which we get. Now, our x in this case, it's our main focus. 2 over 3 becomes our coefficient. Here we have 1 over 3 as our constant term. If you remember that the derivative of a constant term is always equals to 0. Subtract. Here we are going to get 2 over 3, and then we change our x into its standard form. It becomes x to the power of 1 over 2. Now, we know the square root is always rational exponent half, and then the cube root is going to be rational exponent 1 over 3, and so forth and forth and forth. Now we have our expression in its standard form. We can now derive. So from here, since we are deriving, we just write an equation or an equal. You would notice what I did up until the point where I am now deriving. I am not writing any equals. You shouldn't write any equals because you are only simplifying what is inside the bracket. So you're still simplifying the expression. You're not finding an answer yet. So since we are now finding an answer for a derivative, the derivative of a constant, you will then create an equal sign, or you will write an equals to. So derivative of a constant is 0, because we don't have any x that multiplies that. Or even if we have, you have x to the power of 0 here. All right, minus. Now we are going to multiply the coefficient, which is 2 over 3, by our exponent 1 over 2. And then we take x and subtract 1 from our exponent. Okay. What are we then going to get? 3 over 2 times by half, we would get negative 1 over 3. And then after that, because 2 cancels 2 here. And then we have x to the power of 1, a half subtract 1. We get negative 1 over 2. Finally, what we then going to have, because this is a fraction, we just need to be careful about how we're going to write this. We want everything to be written in what do you call it, with positive exponent. The negative will go to your numerator and 1 over 3. Now, you still have 1 over 3. Since x becomes a denominator, you write it as a denominator and then change the exponent to a positive. That's basically how you change this expression by finding the derivative and changing it into its standard form. So this is going to be 1 over 2 there. Well, to get 1 over 2, let's remember where this came from. X to the power of half, we got it from the square root. So this can be written as negative 1 over 3 root x. If you leave your answer with just a positive exponent, you're 100% correct. If you leave it as the square root, that's still okay. All right. So these are the 3 main questions that I wanted us to discuss today. Let's just do the recap and look at different types of questions under derivatives and calculus. The first one is finding the derivative of an expression or of a function from first principle. The second 2 types of questions is finding derivatives using different notations based on the type of questions that are provided. Remember, the key part of find or using the short method is to ensuring that your expression or your equation is written in a standard form first. And once that is done, you are able to actually derive. I hope this helps. All right, and good luck with your grade 12 year. Bye.